Hey, how's it going? This is Rob coming to you with a video solutions for Math 134 Homework Quiz number 4. In this video, I'm going to break down the two questions, one having to do with inflection points and the other having to do with the application problem. All right, so to begin, we need to find the inflection points, if any, of the function given here. So far what I'm looking at, people are getting the right idea. You want to begin by calculating the first and second derivative, all right, because inflection points concern the second derivative. And if you think about it, if you look at the sections here, right, 10.2 was applications of second derivative. 10.3 was curve sketching, which was not covered here, and 10.4 was optimization 1. Okay, so the first derivative, we use the power rule, 18x squared, the power rule, 36x, the power rule, 12, constant goes to 0. Second derivative is just the derivative of the first derivative, so the power rule is used again, 36x, power rule, 36. Many correctly saw and factored out the 36 and got 36 times x minus 1. Okay, and so what we discussed in class, and I know this was a few weeks ago, was that essentially what you're supposed to do is you're supposed to find, first of all, the place where this is equal to 0. So this will be equal to 0 when x is equal to 1. And so what I'm looking for is, in order for this to be a point of inflection, the sign of the second derivative has to change between the left-hand side of 1 and the right-hand side of 1. Okay, so I need to choose a number that's less than 1, and I need to choose a number that's greater than 1. And if the sign of the second derivative changes, then I know that this is in fact an inflection point. Because, for example, if it was, let's say, negative, we'd have concave down. And then if it was positive, we'd have concave up. And so this point right here where it changes, that would be a point of inflection. So let's take a look. I'm going to plug 0. And remember, you're plugging into the second derivative because the second derivative indicates a change in concavity. Now, I had at least one individual, right, work smarter, not harder, choose 0. I don't know why you wouldn't. 0 is pretty straightforward to plug in, and 2. Now, if I plug in 0, right, I get 0 minus 1 is negative 1. Negative 1 times 36 is negative 36. So the concavity is negative, or rather concave down. I plug in 2. 2 minus 1 is 1. 1 times 36 is positive 36. And this shows that when x is 1, the concavity changes from concave down to concave up. Therefore, 1 represents an x value for a point of concavity, or rather a point of inflection, change in concavity. So what you need to do now is you need to take it one step further because it is an inflection point. And a point has an x and a y. So you need to take 1 and plug it back in. Okay, and a lot of people did do this correctly. I did see, I think, one or two mathematical errors here. Just be aware of your PEMDAS. So this would be 1 cubed is 1, times 6 is 6, 1 squared is 1, times 8 is 18 rather is 18, and 1 times 12 is 12, minus 20. So I have 6 minus 18 is negative 12, negative 12 plus 12 is 0, and 0 minus 20 is negative 20. So my final point of inflection is 1, negative 20, because at 1, negative 20, we have a change from concave down to concave up. Okay, please make sure you understood the answer to this, and then in a second I'll move on to our application question. All right. Now, this was an application question here. You might have noticed this was revisited actually from a previous quiz. Unfortunately, I hate to say this, but I did see a lot of very, very, very suspicious answers to this question. some of which were very similar to some online solutions. A number of students have been directly addressed about this, and I will deal with those students. And so unfortunately, I think that those individuals who sought out illicit resources to solve this problem really sold themselves short, because we really did talk about similar ideas to this in the lesson maybe an hour before I even gave this. So to those of you who really took an honest shot at this, I shouldn't have to say thank you, because that's the what you're supposed to do. But really unfortunate, guys, when you don't at least try it and you kind of seek out other stuff, you're really selling yourself short, right? I know some of you might not have to do calculus after the semester, but that's not a way to go through life. That's my little lecture there. I'm not going to go too much into it, but I was a little bit disappointed in some individuals. So I'm going to calculate the first derivative, and to calculate the first derivative, because that's what you're doing. So to break this down, I want to maximize and minimize. So what I'm going to do is I'm going to take the derivative, I'm going to make it 0 to find any critical numbers, and then you notice that I was given 0. Now, you might remember from our previous use of this problem that when you plug in 0, you get 100, right? The highest possible percent. And if you think about it, right before this was dumped into the water, that's when you're going to have your highest amount. So remember, when we talked about the extreme value theorem, any function that's continuous, differentiable, defined on a closed interval, at least we have 0 in our closed interval, will have a min and a max. So we need to try 0 as one possible number, just like we saw in class, and a few different examples. And then we need to try any critical numbers that come out by virtue of the derivative being either 0 or undefined. So many identified that correctly that I'm going to use the quotient rule. So I'm going to color the low red, and I'm going to color the high blue. So I have low d high minus high d low over the bottom squared, and away we go. So let's break this down. From this point on, I'm going to go back to using black ink. I just want you to see how I broke that down a little bit with colors. So low stays the same. D high, so the derivative of t squared minus 4t minus 4, or plus 4, we use the power rule. Power rule. Okay, high stays the same, t squared minus 4t plus 4. Derivative of t squared plus 4 is just 2t. Over the bottom squared again. All right. So now what I have to do is I've got to do distribution here, a little bit of cleaning up. So I distribute here. I've got 2t cubed minus 4t squared plus 8t minus 16. All right, let's check that again. So 2t cubed minus 4t squared plus 8t minus 16. Okay, now I distribute the 2t minus 2t cubed plus 8t squared, because that negative switches it to a plus. Now this is a minus 8t. Okay, again, all over the bottom squared as is. T squared plus 4 parentheses squared. Let's see if we can do a little cleanup. So I've got a 2t cubed and a negative 2t cubed. Those are going to knock off. I'll highlight this because those are like terms, but they're not going to cancel. The 8t is going to cancel, and I'll have a 16. So what I get is I get 100 times, it appears, minus 4t squared minus 16. That, and this actually, you know what I think about, that actually makes sense now that I think about it. I just want to make sure I've covered all my bases here. Minus 4t squared. Okay. Oh, but then when I add the 8t squared, that's why I'm getting it. It switches to a positive because it's a 4t squared plus an 8t squared. There we go. I knew it was, because in my answers I had it being positive in the end. There we go. Okay. I can simplify this further. Technically, you could pull out the 4 and make it a 400. That might be easier for you, so I'm going to factor that out, and it becomes t squared minus 6, minus not 16, minus 4. Okay, so then that is the derivative. So if I'm going to make this 0, then essentially all I need to do is solve t squared minus 4 is equal to 0. And the reason I have to do that is because essentially I'm trying to find the critical number. So I guess I could make it undefined as well, because we know critical numbers will always make the derivative 0 or undefined. Now, this is a fraction, and in a fraction, we'll have undefined when the denominator is 0. But we know that the denominator cannot be 0, because t squared plus 4 is never equal to 0, because there is no real number that when you square it gives you negative 4. You'd have to have imaginary numbers to solve that, and we're not working with imaginary numbers here. So I add the 4, and I get t is equal to 2 or negative 2. And as we talked about in class, I now need to go up and I need to realize, wait a minute, time can't be negative. So negative 2 is not an option. So 2 is my number. So basically 0 is one critical, is the given endpoint, and 2 is the critical number. So I need to try both of these in the original function. Okay, so if I plug in 0, I get 0 squared is 0. Okay, so this is 0. So I get 4 over 4, because you can see this will all go away when you plug in 0. So it's 1, and 1 times 100 is 100. So let's undo that. Then I plug in 2 to the original function. 2 squared is 4. And not like this is going to be the minimum, but to cover our bases. 2 squared is 4. 4 minus 4 is 8. Okay, 8 plus 4 is 0. So the numerator is 0. And then immediately 0. It doesn't matter what's on the bottom. Well, technically the bottom couldn't be 0, but I can see quickly the bottom is going to be 8. Okay, so to be technical, this is 0 over 8, which is 0. And 100 times 0 is 0. So 2 goes with 0. So what we know is the maximum is at 0 days. And the minimum is at 2 days. Now, I'm going to address this right now. Any one of you who put 3.5 as an answer, that's going to go ahead and set off a lot of red flags. Because one, where would you have gotten 3.5? Now that you've seen me do this problem, where would 3.5 have come from? It's not a critical number. If you took the second to graph it, then you'd know that it's not a maximum. It's not anywhere near a maximum. So guys, I'm going to say this again. I said this in the first day of class, and I hate to say this again on a video, guys. I check online solutions. 3.5 is not an answer to the problem that I have asked. It is the answer to a similar problem which has been asked and which appears online. So I'm going to say it again. I check Chegg. I check Course Hero. I check Bartleby. I check all of the Yahoo Answers, Reddit. If you submit work that looks like work online, I know what to look for. I will look for it, and I will tell you that I have brought it to a number of individuals' attention for certain people in the class. If you are in a state where you don't know how to answer questions like this, what you need to do before you resort to things like that is you need to Seek me out for extra help. I had individuals come before class online and ask for questions. You need to seek out help from someone, because if you seek out online resources, at some point I am going to catch you and it's not going to end well for you, okay, in terms of your standing in this class. So thank you for watching. I appreciate it. Keep the questions coming. Please feel free to review this video whenever you want. It will be online. And remember, you can do it. Okay, thanks again for watching. Have a wonderful day. And don't forget to love math.